Everyone, this is part 2 of the self-quiz, and it is algebra word problems, work and motion. Alright, you've gone over the basics with me. I've had you try some problem sets for these two different kinds of algebra word problems, and now we're at the final video, self-quiz 2. We're going to focus on motion problems. As I explained in a previous video, the formula we're using for all these is distance equals rate times time. The distance traveled equals the speed times how long it took you. All right, now the units vary depending on whether you're talking about miles per hour, feet per second, whatever units you're using, this formula always works. Now I looked at this structure here with you and I said, okay, on the left side you have distance, we'll call that D. On the right side we have rate times time, we'll call that R times T. But if we put it in this sort of a structure, almost like a ratio here, if you are asked for distance, you cross it out or ignore it and you will get rate times time. That's how you find the distance. All right, what if you're being asked the speed or the rate at how someone travels? Well, ignore the R or cross it out and circle what's left. You're going to have D divided by T, so that line becomes a division line. All right, what about time? If you're asked how long something takes to travel a certain distance at a certain speed, well, you're going to cross out the T, that's the unknown part, and what's left? D divided by R. All right, so all you need to do is remember D equals R times T, but split it here with the line. There you go, there's your formula. All right, here are two problems I want you to try. So read them, pause the video, and come on back, I'll show you how to do it. All right, the first step, I think, is to draw the proper diagram. Then we can figure out the formula and the equation to write. Now it says Jessica made a trip to the train station and back. All right, so here she is going to the train station, and here she is going back. Now notice that the distance is the same, right? Okay, that's kind of a key part of this. Now, let's think about the distance here. This is her distance going in this direction to the train station. This is her distance going home from the train station. We also talked about how distance can be written as rate times time. Okay, so I'm going to put that in both places. Now let's fill in the information that we know. All right, do we know the actual distance to the train station and back? No, we do not. Okay, but what was her speed going to the train station? Well, it says she averaged 10 kilometers per hour faster on the return trip than the outbound trip. So we're going to call this R, and this is going to be R plus 1. Okay? Now, what was the time for her trip to the train station? 5 hours there. So let's put in the 5 right here for T. And what about back? 4 hours there. So let's multiply that by 4. All right, we're going to use this information to write in our equation because this distance equals that distance. So 5 times R is her distance, or excuse me, rate times time going to the train station, and R plus 10 times 4 hours was the distance going back. These distances are equal. So we have 5R equals 4R plus 40. All right, how'd I get that? That's the distributive property, isn't it? So 4 times R, 4 times 10. All right, let's subtract 4R from each side, and you'll see that this actually works out pretty nicely. So 1R, or just R, equals 40. And again, we look back at the problem to see what our units would be, and it's kilometers per hour, 40 kilometers per hour. All right, number 2, the answer is 30 kilometers per hour, but let's go ahead and draw a diagram. All right, number 2, Jose left the mall and drove west. Jenny left 2 hours later driving 20 kilometers per hour faster in an effort to catch up to him. After 3 hours, Jenny finally caught up. So my first arrow here is Jose, and he's already left. And then we're going to wait 2 hours later, and then Jenny, going faster, eventually catches up. So notice those distances would be the same because they are now caught up. All right, once again, do we know the actual distance traveled that Jose and Jenny went? Well, we know they're the same as each other, but we don't know how many kilometers that was, so we'll ignore the D part. All right, now for Jose. Well, we know that Jose, Jenny caught up after 3 hours, so we know that her time is 3. That's how long she traveled. And Jenny left 2 hours later than him, so he must have been traveling a total of 5 hours. Okay, got to do a little detective work and figure that out. She drove 3 hours, he drove 5 hours. But the rate, what was his speed? Well, we'll call that R because Jenny drove 20 kilometers per hour faster. She was faster. So instead of R, it's going to be R plus 20. All right, very similar to the previous problem. Now let's put this together in an equation. So Jose's distance traveled is rate times time, 5 times R. And Jenny's distance traveled is the same because they're caught up now, and this is her speed and this is her time. Distance equals rate times time. All right, remember we're going to do distributive property here, and so our new equation really is 5R equals 3R plus, don't forget to multiply again there, that would be 60. All right, let's subtract 3R from each side, and you'll see that we get 2R equals 60. And of course, when we divide by 2, we're going to get our answer, 30 kilometers per hour. All right, so we got to read the questions carefully, draw a diagram that helps, and just remember your distance formula. Distance equals rate times time. All right, thanks so much for watching this video. Share it with others and send me some comments.